forgot to push record yesterday, so hopefully you didn't need yesterday's discussion. Okay, so what I want to do, there's two tabs on this lab, and I've been showing you, and I said this yesterday, I've been showing you how to find the 5-number summary and how to find the standard deviation and the mean and the median and the mode and all those kinds of things. And we know how to do that in the graphing calculator a little bit. We haven't practiced it a lot, but how to do it in Excel. So what I'm going to do is this first tab here, descriptive statistics commands. I'm gonna do all of this with you. This is not part of your assignment. You can just watch this. You don't need to do this. You're welcome to do it with me if you want to make sure you know how. And I would kind of recommend it because you can look back at this later and kind of see what to do. Because again, you're going to be doing this for your final project like a month and a half from now. So again, don't be afraid to write notes over here. Like I found this command over in section 7 or whatever. I mean, write yourself some notes in this if you need to, because I want you to know this long term and save this so you can show somebody you know something someday. And then over here, this is going to be you actually doing all of this with an actual project. And so notice you've got a whole bunch of price per square foot for a house. So this is all the price per square foot from houses in Central Point. I was selling my house a few years ago and I was thinking, how much should I sell my house for per square foot? Obviously some houses are big and some are small, so you can't compare just house prices. You have to compare how much they're charging per square foot. And so notice in that big list, I'm asking you for the mean and the population standard deviation and the minimum and Q1 and Q2 and Q3 and the max. And so that's the 5-number summary. And then using the IQR method, can you find the lower fence and the upper fence? And then based on that, are there any outliers? Are there any houses that were ridiculously cheap or ridiculously expensive? And what was the Z-score that goes along with those? And then can you construct for practice another bar graph from this? This is a huge takeaway for this class. Like for the most part, when people said, you know, get your bones into statistics or you can't be a nurse or, you know, whatever it is you're going into, this is kind of why, like right here, this is kind of everything right here. So I just want to show you back here how to do all of these commands. Now you don't have to memorize anything here. Cool, to select commands, go to the formulas tab, more functions and statistics menu. I never go there because I'm telling you what to type right here. But let's see, what did I say? Formulas tab, there's the formulas tab up on top. And then here's all the different commands that exist in here. And statistics isn't one of the primary uses of this. So if I go to more functions, statistical, like here's all of the different commands in Excel that will do things in statistics. Notice, wow, that is a gigantic list. And so anything you ever would want to find, notice there's standard deviation right there, for instance. Anything that you'd want to find, you could find it in here if you didn't know what you were looking for. But I'm just going to type this. And again, learn something from this. Watch this. I've already shown you some of this. So I already showed you the mean, the average command. So I'm just going to go into this cell and it says, there's the command right there, equals average. So if I click up here, and again, interrupt me and ask questions here, equals average. And here's something kind of cool. You always need to start a parenthesis. And when you do that, and by the way, just notice something that just happened for me up there. There was a space right here and it like the space was there and it didn't like that. So I got here and it was like, wasn't doing anything, but it's like, oh, that space isn't supposed to be there. Well, notice it tells you what it's looking for. It wants to find the average of number, comma, number, comma, number, comma, number, comma, number, comma, number. In other words, you could sit here and type them all. But in our case, way easier. And because I'm in this command, I can actually just go over here and grab them. Do you notice this first number is in cell A8, and then this last number down here is in A38. So I could grab this and just drag down, which is way easier, or I can just type it. This time I'm going to type it, which is a waste of time. A8 colon, not semicolon, colon, and then A38. So instead of me typing all of those numbers, I just said, hey, all my numbers are from A8 down to A38. Do you see the little blue box on here showing what I just typed. You see how it's in the right location? So it's kind of like, oh yeah, good, you got it. Now, and this is kind of important, you can either hit enter, but don't just click another box, because if you do, it still thinks you're trying to do something with this command. Or that little green check mark, that's kind of another way to hit it. And notice it says, bam, there's your mean. So these numbers have no purpose, but there's the average of them, 10.8, cool. So average is one of your commands, that's for mean. And then standard deviation. Excel uses equals STDEV, standard deviation dot P for population, or standard deviation dot sample. Notice here I didn't say which one. So again, I'm just going to start typing that, equals STD. And notice down below, it actually kind of pops up your options down there. So you could actually just click one of them. I'm going to click that. I double clicked it. And again, notice it's asking for, okay, what numbers do you want to type in? Well, this time I'm going to do the smarter thing and just click and hold and then just drag this over here. And basically then it's just going to type. See how it just typed automatically up there for me, what I was just typed by hand before? Those are both fine. So I close the parenthesis. This time I'm going to hit enter. Bam, there's your standard deviation, 2.8. Little side note, notice I must have formatted this so that that number was centered and bold. I didn't do that here apparently. Just for the fun of it, I'm going to do it now. If I click here and go back to home, like here's all my centering commands. And so there it's centered. I turned it red. I made it larger. Like you can always mess with stuff if you want to. I made it bold. So if you are doing this for real, you are going to want to make it nice and presentable. So sometimes that kind of thing is cool. So notice, hey, this is actually pretty easy. All of these are the same thing, equals median, equals minimum, equals maximum. Do you notice they're not in order over here? So therefore it's going to be hard for me to tell what the minimum and the maximum is. Well, if you're lazy, then just say, go find the minimum for me. Equals minimum, drag down all these cells. Close that off. I'm going to click the checkbox this time. Oh, the minimum's 5. And you could look over there and kind of see, oh yeah, there's 5 right there. But it's kind of nice that it just goes and finds it for you. Wonder what the max is, equals max, A8 colon A38. 17. 17 is my biggest number. Median. Remember, you got to have these in order to get the median by hand, but it's kind of cool that you don't even have to have them in order. Equals median A8 colon A38. Bam, there's the middle number, 11. 11's the middle number on that list. So a lot of the key numbers that we've been trying to find lately, this will just find them for you, as long as you know a few basic commands. And so right here, I'm telling you, when you're over on this page, you're not going to have all that memorized. And so, being able to pop back over, what was that command again? And kind of look at this page. And then even the quartile thing. Now, does it make sense in the 5-number summary? Isn't this the first number here? 5 is the first. And then the maximum is the last, and then the median is the middle one. So the only two I don't have are Q2 and Q3. I'm sorry, Q1 and Q3. And remember, that would be a pain, except for, hey, somebody realized this is kind of important. So they invented a command in here called quartile. So the command, Excel uses equals quartile command for quarters. And so cool, here we go, equals QUAR. Oh, look, notice it shows up down there. And then there's a couple of interesting, I actually don't understand this, but notice one of them is like quartile execute, quartile, I don't even know what that is, INC. Inclusive, I think that's what it is, exclusive, inclusive. So there's exclusive. Actually, I'm not sure what that means, but the regular quartile command is right down there. It's like, I don't really need. Spelling counts, by the way, if you're typing this and you spell it wrong, it's not going to work. Yeah. So it's like they came up with, and by the way, notice I have this note here, this command will often disagree a little bit with the correct answer. In other words, it has trouble sometimes getting that exactly right. I have a feeling that probably they fixed that. And some of the, like I'm using sort of the older command, but they probably one of those two, exclusive, inclusive, that's a thing, but I don't want to get off into the weeds about that. But notice, do you notice it's asking for two things here? Notice it says array, comma, quart. In other words, that's what it needs. That's what it needs for ingredients. And the array is just a fancy way of saying where's the data. And then the quartile is saying, well, which one do you want? Quartile 1 or quartile 2 or quartile 3? Because you got to say which one. So my array is all these numbers over here, just like it was before. And then the command says, and notice this array is black. You see how it's highlighted? And so then if I go in and I type a comma, do you see how it suddenly, let's see, can I see this? Notice I just click somewhere else. If you start clicking other places, it thinks you're trying to hunt for things. And so it's like, that's one of the things that can kind of screw you up. But notice it, now you put a number in. Which quartile do you want? Isn't this interesting? It actually gives you 0 for the minimum value, or 1 for the first quartile, or 2 for the median or the 50th percentile or second quarter, or 3 or 4, which would be the max. Like you could actually get all the 5-number summary just from using this command alone. I'm after Q1, so I'm just going to put a 1 here. And then close the parenthesis, and it says, bam, it's 9. So that's the median of the bottom half. Does that make sense? Now, if you're really lazy, watch this. So don't I have to just redo that exact same command over here for quartile 3, except put a 3 there? So here's what you can't do. If you grab this and say copy, don't do this, and you say paste. Do you see how I copied that 1, 2, 3 places to the right? Well, do you notice what it says right there? Do you see how it says, oh, I'm now looking in D8 to D38? It actually moved everything 3 places to the right. So that's not really what I wanted to do. If you do want to copy something, but you don't want it to do that, one way to do it is just to go up here. Don't copy the entire box. Go up here and copy the command. So I'm saying Control C for copy, and then check box to get out of that. And then go over here, click up here, Control V for paste. And notice I just got the same exact thing. And all I have to do is go back and put a 3 in. Is there anything wrong with just typing it again? No. And so notice there's quartile 3. Now, watch this closely, because I want you to use Excel. Like, don't break out your calculator and do stuff with your calculator. Let Excel do its thing. So to find the inner quartile range, don't I need to go Q3 minus Q1? Now, couldn't you maybe even in your head look at that and go, hey, 12.5 minus 9, that's 3.5, and just kind of type it in there? What would happen? I don't know. Number lock is turned off. Then just type 3.5. That's not wrong, but it's kind of cool not to have to work so hard. And in this case, I got kind of lucky because I could do it in my head. But the point is, don't break out your calculator. Use cell references. What do I mean by that? I mean this. Say equals. Well, don't I want to go 12.5 minus 9? Well, just click that cell. Isn't that cell L14? You could type L14, but just click that cell. And then say, and I want to take that and subtract. And then this is I14, but I'm just going to click that cell and then say done. So it's like it's doing it for me. Like, don't let it do what it's meant to do. Don't get your calculator out and figure this out yourself. So there's the inner quartile range. I used the cell reference, and part of when I grade your assignment over here, that's what I'm going to be looking for. See right here, it says use cell references for full credit. Like, I should not look into this box right here and see a number. I should see equals, average, and then all of these cells selected. Like, I should not, don't do this in some separate place, do it in Excel. I want to see cell references in all of these when I grade it. Otherwise, you're just making your life hard. I know you kind of know it on your calculator, but keep in mind, in the real world, nobody uses your calculator to do stuff like this. They use Excel because it allows you to display it and, you know, print it and do beautiful things with it. And so that's why we require it in this class, because we want you to be able to actually use it in the real world. And then lastly, same thing. Couldn't you get your calculator out to find the lower fence? Here's the formula for it, right? Q1 minus 1.5 times IQR. you might, and I don't want you to do this, get out your calculator and go, oh, that'd be 9 minus 1.5 times 3.5. Like, get your calculator out. That's too much trouble. Like, use cell references. Say this cell is going to equal this cell minus 1.5 times, notice the symbol for times is that asterisk above 8, if you didn't know that before in keyboards, times the IQR, which is right here in cell K23. So there's the lower fence. So when I click on this button, I don't want to see 3.75. I want to see all of this cell reference up here. Like, this is what algebra looks like in the real world. People don't do 3a plus 2b equals 7. They're actually referencing cells. It's like, do you see that as an algebra form? And what's really cool about this, watch this carefully here. I'm going to go over to this number. Let's say, like, oh man, I screwed up. That's supposed to be 60. It's supposed to be 60. I typed it in wrong. Does it make sense? Because all of these formulas here are looking over at these cells. If I fix this to 6, then every single one of these is going to change automatically, and I don't have to redo it all. If you push this into your calculator and you screw that up, guess what? You got to do the whole thing over again. So I can go over here and say, oh, that was supposed to be 60, and watch what happens. Every one of these numbers just updated now. I got a way higher average than I had before. I mean, everything just changed. I didn't even have to do it again. Do you see the power in that? Like, this is work to figure Excel out. I'm not assuming you've ever touched this stuff before. It's not as though I say it once and you're like, oh, okay, I got it. I'm going to walk around and give you a chance to ask me questions, but it's like, this is a powerful tool. Put the time in to learn how to use it. It's really cool. So, and then lastly, let's see, the upper fence. Isn't that Q3 plus 1.5 times this IQR number? So I'm going to say equals this cell plus 1.5 times this cell. Enter, bam. So now I've got my fences to go looking for outliers. So do I have outliers? Well, my minimum was 5. So notice 3.75 was the lower fence. There's nothing below that. So since 5 was the minimum, there's nothing below 3.75. So I have no lower outliers. My max was 17 and the upper fence was 17.75. So I don't have anything over that. There's no outliers in this list. This is all the numbers are pretty typical. So based on these calculations over here, I basically have everything I need to know to kind of describe these numbers, even though they were never sorted. And so in this context, where I'm going to turn you loose on now, in this context, though, we're talking about something that would be very valuable to a real estate agent, to me who is selling my house, to contractors who are trying to cost their house, or people trying to sell their own house. And so being able to make these kinds of calculations and in a way that's kind of beautiful, that's kind of a key. That's kind of important. I don't remember how I formatted these cells over here. Did I format them so they rounded off nice? Keep in mind, if you get a mean that's something like 3.892647, like, does it make sense? You wouldn't really want it to be that long. Just watch this really quick. If I went over in this cell and I said equals 665 divided by 7, you see I get a decimal that kind of goes on forever. And I'll even make that cell a little wider so you can see it even goes further. Does it make sense you wouldn't want to report that to somebody maybe with that many decimal places? So again, for the sake of the person who's reading it, it's kind of cool to do this. If you click on it, you see right here where it says number? This allows you to basically round it up or down. I never remember which way to go. Yeah, it's that way. So see how if I just rounded that number down. Notice it says 9.286. So watch what happens if I take the 6 away. Do you see how it just went up to 29? Because that would be rounded correctly. So if it was money, does it make sense that people would want to see $9.29, not, you know, all the ridiculous decimals? So if you get numbers over here that are large or weird, maybe you want to round those off. I can't remember if I set that up for you automatically. And then, as I said before, you can always center those if you want it to look nice. You can make them red, you can make them bold. I mean, you can change their color if you wanted to. That's not hard to do. These are things that are good skills to have if you're going to use this for something in the real world. So I just want to shut up and give you some time. This isn't due for I want to say it was the 25th. I mean, this isn't due for a long time. You have plenty of time to ask me questions about this. So I'm going to give you maybe, I don't know, 20-ish, 30-ish minutes now to make some progress on this. And again, as always, you're more than welcome before you just turn it in to me, you're more than welcome to call me over before after class and say, does this look good? I want to get an A in this class. Is there anything I need to do differently? Both because you want a good grade, or second, just because you want to learn something. And I'd like to talk with you one-on-one. You'll learn more if I do that. Okay. I'm going to shut up for a little bit and walk around. Let's see, I'm going to turn off the recording of this so I'm not recording nothing. Pause recording. Okay, I want to show you something else in the last, I don't know, maybe 15, 20 minutes here that pertains to chapter 4, but then you'll still have some other time to work on this too. So I apologize for interrupting, but we won't get done everything we need to get done in this class if we don't get started on this. This is the last thing that's really before the next test. So what's chapter 4 about? It's really when you have two sets, not one, of related data. Like right now, you're looking at house prices, and it's just one list. Hey, here's all the house prices, right? Well, this is two different sets. So let me show you what I mean. So this is a Versalam. I've mentioned to you that I draw house plans, so I'm always putting these in houses. And so it's basically just a beam that's in a house. Does it make sense that there's probably a relationship between the depth of it? This is the depth right here, like how tall that is. In other words, different heights would have different strengths. You don't need to know what shear is, but basically the simple principle of shear is, does the beam want to just rip in half, like in this direction? So does it make sense if you have a bigger depth, then you'd have a stronger beam? So I'm just looking at these two columns. Or perhaps if you had a bigger depth, would you have a heavier beam? Notice when it's 5.5 inches tall, it weighs 4.9 pounds per lineal foot. When it's deeper, 7.25, the weight goes up. 9.25, the weight goes up. You see it just goes up, up, up. Like, do you see how there's a relationship here? It's not just one set of numbers. It's how does one set of numbers relate to another set of numbers? So this is a really powerful idea. And in a practical sense, it might be something like, hey, you go to the doctor, they take a measurement of something in your body, glucose, whatever, and like, man, that's really high, you're in big trouble. So then they say, go home and exercise, or, you know, eat differently. And so you eat differently, and maybe you take a measurement of that. Hey, I ate this many grams of fiber, and that's what I'm supposed to eat. And then they took a measurement of my blood, and I got a better value. And then I went home and I ate a different amount of fiber, and then they took a measurement and I had a different level of blood. Like, that's the whole point, is like you do something different with something in your body, and then you're hoping it'll make a difference someplace else. It's like two numbers are related to each other. Or, hey, I'm not doing very good in a class, and so I'll work harder, and then I want the grade to go up. So I work more, I get a better grade, that kind of a thing. So how are two things related to each other? Does it make sense that that's a thing? So in my case, this might be one of them. Well, here's the cool thing. And so I'm just going to make a rough graph of this, and we'll pick this up next time. But I want to look at just these two. So again, assuming you don't have any algebra knowledge at all, let's see if we can make this at least decent. So what's cool about the brilliant design of a graph of something is it actually allows you to show what this relationship actually is. So would you agree, even if we don't worry about the numbers, that obviously as the depth gets bigger, 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 the allowable shear gets bigger, 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 bigger too? So it looks like there's some positive relationship. When I make the beam bigger, it gets stronger. That sort of feels right. That makes sense, I think, to you. But let's actually see what that relationship is. And so I'm going to choose to put the depth down on this axis. And I'm going to put the shear over on this axis. Now, do you notice the size of the numbers, though, are really interesting? They're gigantic. And so let's see, I got to get from 5 to 20. So maybe I'll try this. Maybe I'll mark this as, oops, that was a mistake. Thank God for undo. Maybe I'll call this 10 and this is 20. And so then this would be 5 and this would be 15. Does that look reasonable across there? So it'd be nice to do this on graph paper, right? But then notice for the numbers on shear, they're huge. They're really big numbers. They go all the way up to 13,000. So let's see, to make it easy, what am I going to do here? I don't know. 5,000. Yeah, maybe go 5,000 at a time. Does that make sense? So maybe go 5, 10, 15. I kind of like the sound of that. So maybe I'll go 5, 10, 15. And because that's an awful big number to write, I'm just going to write 5K for 5,000 and 10K for 10,000 and 15K. And so here's what's cool. So now what I'm going to try to do is, well, reference both this and this at the same time. So if I go over 5.5, let's see, can you do this with me? If I go over 5.5, that'd be somewhere in here, and I won't get this perfect. This would be 7.5, so this would be like 6. So 5.5 maybe is about right there. And then that's paired with 3,600. So I don't know, I got to go below 5,000. So would that be maybe right in there somewhere? Can you appreciate like using Excel to do this would be nice? Like I could actually get it to make it perfect. And I'm going to show you how to do this on your graphing calculator in just a second. But maybe it's like right there. Now here's what's so powerful about this invention. Now this stuff got jammed down my throat in like an algebra class, and I never understood like what is this? I don't really understand what I'm doing. But you see what's amazing? That's actually one dot. Yet because it's placed on 2 axes, it actually records both numbers at the same time. Isn't that that's kind of cool? So I can see that it's 5.5 for depth, and yet and I would never be able to see this from the graph. I'm not going to be able to tell that's 3,658, but let's keep going. I'm just going to just graph a few random ones. Let's see, let's jump up to this one, 9.5 and 6,300. So 9.5 would be about there, 6,300, I don't know, what do you think? Maybe right there. Is that reasonable? And then I'm going to skip up to 14 and 9310. So 14 and then just under 10,000. Does that look reasonable? And I'll do the last one, 20 and 13,000. So 20 and maybe right in there. Do you notice those points are not just random? They're not just scattered randomly all over the place. There seems to be kind of a pattern to this. And I would say at a glance that pattern is actually a line. Do you agree with that? In other words, this pattern seems to be really good. These points are not scattered randomly everywhere. And so if you're trying to show relationship between things, is there a direct relationship between depth and shear? It appears that yes is the answer to that question. It's really closely related. So let's look at a couple other things. Let's see, I want to stop sharing. Let's look at this relationship. Do you think there's a relationship between age and pulse? We took our pulses earlier. In general, I kind of think of like older people have a worse health. So maybe if there is a relationship, as you get older, maybe your pulse gets higher. I don't know. Is there a relationship? Or is there not? Like, is there young people that have really high pulses and young people that have really low pulses and old people that have high pulses and old people that have young pulses? Well, I did this in another class. I won't take the time to do it here, but here's what I saw. There's the graph. So there's the data. A 29-year-old had a pulse of 100, a 35-year-old had a pulse of 92. Again, do you see I'm trying to relate two different numbers to it? And notice when I graphed it, what kind of a pattern do you see there? Notice it's like, looks like a shotgun, like it's everywhere. There's not near as much of a relationship. Does that make sense? And so, now I'm thinking to myself, based on my little tiny study here, I'm thinking, well, maybe there isn't a relationship between age and pulse because I don't see much of a pattern there. And so that's kind of what we're looking at next, because this gives you the ability to kind of predict things. And so apparently age has nothing to do with pulse. If I wanted to figure out somebody, like what effect age has on somebody, maybe I better check something else than pulse, because it doesn't really seem like that's very closely related. Let's see, let's look at something else. What's this one? I don't know. Height and weight. You think there's a relationship between people's heights and people's weights? So this is the Ducks football team. Do you think there'd be a relationship between height and weight? Part of me thinks yes, because if you're taller, that's going to cause you to weigh more. But then, of course, there's all kinds of different body types. Like there's short people that weigh a lot, and there's tall people that are really skinny. And so does it make sense this probably isn't going to be perfect? It's not that simple. Well, watch this, because I'll just do this. Let's see, did I already do this in here somewhere? No, good. So you saw me make a graph a second ago and I labored at it and it wasn't all that good, but watch how easy this is in Excel. So I'm going to grab all of their heights and weights. And I'm going to go up here to insert, and you just did this, right? Like we've been inserting graphs, but where I'm going to go here is not to a bar graph, but right here to something called a scatter plot. Well, that's what I just did a second ago with the beams. I plotted the X and Y coordinates. So I'm going to do the same thing here, and it's called a scatter plot just because it might scatter everywhere. So, and notice I can connect them with lines. Notice that makes it totally confusing. But what I really want is just the dots. Now, this is interesting. How come there's like dots all stacked on top of each other? Like take a second and try to read this. Notice it's not labeled. So we actually have to think about this ourselves. That X was the height and the Y was the weight. Where did it go? I don't know, where did it go? There it is. So these are the different heights. Well, notice their heights are recorded, although their heights would be continuous, they were just recorded as discrete numbers or rounded off to the nearest inch. And so you have a bunch of people that were 70 inches tall and then 71, but nobody in between. So notice for people that were, say, 74 inches tall, notice there's a whole bunch of different weights there. That kind of makes sense, actually, doesn't it? Yet, do you think you see a pattern there? Is there a general relationship? Is there kind of a line? Does it seem like it's actually working its way uphill, even though it isn't perfect? So there is kind of a pattern here. Is there a relationship between height and weight? Yeah, there actually is, but is it perfect? No. Notice this person over here, does it actually say what that person is? I can't see that it says what that person is, but notice their weight is between 200 and 250, and yet this person over here outweighed them, even though they were way shorter. So like, is it perfect? No. But is there kind of a general uphill kind of a relationship here? I'll be showing you this later on, but I'm going to add one. I'm going to add what's called a trend line to this. And this is one of the labs we'll do later on in this class. So I won't show you the details of it now. But does it make sense? There is kind of an upward pattern to this. Now, it's not perfect. You can't predict it maybe near as good as you could in the one that I started class with, but there is kind of a relationship there. But as you know, there's other things that affect weight than just height. It's certainly one of the contributors, but it's not the only thing. And so that's kind of one of the main points of this section. It's kind of this scatter. Let's see, let's just look at something else. Actually, I want to show you something kind of cool. You know how weather's done? Weather balloons go up. Did you know this? Weather balloons go up at the same exact time of day all across this country. So there's a weather station right up by the airport, and they send a balloon up at 3 o'clock every single day, or 4 because daylight savings times makes a difference. But every state and all over the state, there's balloons that head up across the entire country, and they're basically measuring temperature and pressure as they go up. And so that's kind of why we have weather reports. Here's weather balloon data. Uh-oh. Hopefully I have this some other place. I do, good. Here's weather balloon data for our region. I can't remember when this was. Maybe it says up there at the top, October 2012. This is really interesting. So do you notice that there's a pattern there? Well, let's take a look at that blue one. Do you see how it, as, let's see, balloon elevation, as the elevation went up, 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 notice 20,000 feet, 40,000 feet, 60,000 feet, 80,000 feet, something went down, 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 down. What goes down as you go higher and higher and higher? Nice and loud. Yeah, oxygen. Isn't there less oxygen up there? What else? There's actually quite a few things. Oxygen does, temperature does, and pressure does. Pressure goes down too as you go higher, higher, higher. That's why we have altimeters in airplanes, by the way, is because somebody exploited that relationship. Now notice that blue one isn't a line, but there's definitely a pattern to it. Does that make sense? And that's something you study in higher algebra classes. Well, what is this actually measuring? Notice I didn't label the graph over here. So do you notice that's kind of not cool? Like the graph isn't useful, right? Like I said, weather balloon data. And then down here, I said balloon elevation in feet. So at least you know what those are, but notice you don't know. Is that pressures, temperatures? You don't actually know what that is. So what is that? I'm going to click on this to see because I actually don't remember. Oh, it's pressure. As height goes up, the pressure goes down, 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 down. So that's kind of cool. I think if I click on this and hit delete. So notice that pattern is not a line, but do you see how that relationship is perfect? Like that's the only thing that affects pressure. If you know your elevation, then you know your pressure. If you know your pressure, you know your elevation. That relationship is not scattered everywhere at all. And again, this is why we have altimeters in airplanes. If you've ever flown and you landed in the fog, you're very happy that somebody figured this relationship out, because you can measure the pressure from your airplane and automatically use a graph like this to determine what your elevation is. And then you know, oh, the airport is like 3 more feet below me. I mean, you can literally land without seeing. That is unbelievably cool. So we exploit these things. This is really cool. But do you see what I'm saying? This is like 2 numbers. Notice if I just stare at this a little more slowly, here's my height in feet, and there's my pressure. And then I get higher and notice, look, the pressure's going down. I get higher, the pressure's going down even more. And so I can't see this from here. I just see like a big pile of numbers. But if I make a graph of it, all of a sudden it's like, wow, that's really cool. Look at that relationship. That's kind of awesome. What's this other one? This is really interesting. Notice I clicked on it. So what is this doing? This is height and temperature. Height and temperature. What is going on with that? So this, for a while here, it looks like as it went up, the temperature got higher, higher, higher a little bit. But then the temperature started dropping, dropping, dropping. And when you get to 60,000 feet, notice what the temperature is up there. Notice on this particular day, it was like 70 degrees at the ground. So it's a pretty nice warm day. And what was the temperature when you got up to 60,000 feet? Because you tied a bunch of hot air balloons to your lawn chair and you're like, I'm gonna go flying. What happens when you get to 60,000 feet? You're at negative 60 degrees. And so you freeze to death and die. Isn't that crazy that it can be that cold up there? And then weirdly, it starts to go back up again. When you get to 100,000 feet, it's actually going back up again. Isn't that a crazy relationship? But there's definitely a relationship there. Incidentally, I think this is where you hit the ozone layer. Like as soon as you get outside of our atmosphere, then you're not protected from the sun, and now the sun's rays start to actually warm it back up again. I actually don't know for that for sure, but I think that's what's going on. So that's pretty interesting. So notice these relationships, these are good. Like that's really closely related. This is not scattered everywhere. But the relationship is not just a line. And again, you would have to take a really advanced algebra class to try to find some equation, some predictive equation, so that you knew this. But again, don't we exploit this? Because I was just in an airplane over the weekend, and I think airplanes fly at 30,000 feet. You know, it's like a good thing somebody figured that out and kind of adjusted the cabin pressure so that we're not all at 0 degrees up there. At 30,000 feet, it looks like -20. It's a good thing I didn't know it was -20. It's a good thing they figured out how to make an airplane that's got a heat system in it. That's pretty amazing. So this is the idea behind what a graph can really do. What we're going to study in this class is just relationships that are linear, line-like. So let me show you just one last thing, and then you can work on something else or get the heck out of here. So I want to add something to this. And these are the two things we need to figure out. How to get an equation that models that. Notice I didn't do any work now. I just got it for free. And then also there's this thing called an R value, a correlation coefficient. Do you see how that says, like, hopefully you can see that from where you are. Zoom in a little bit. Do you see how that number could be thought of as a percentage? You see how it says like 50%? Well, that's kind of saying this isn't a very good match. This doesn't match all that great. If I did this with something that matched really well, then it's going to say something more like 99%. It's kind of an expression of how line-like is this. Notice this is basically saying this is like 50% accurate. If you want to basically see how tall someone is and then guess their weight, you got like a 50% chance. Like it isn't very accurate. So something that's scattery like this is going to have a low number, like 50%. Something that's really accurate, it's going to be a little bit higher. Let me show you what I mean. This is the one that we just did a second ago. That's the one I just did a second ago by hand. And do you see how it's really lined up nicely? So watch what happens if I click on this and ask it to tell me what that number is. Do you see how it says 1 right there? 100%. That is perfectly accurate is what it's saying. So if you have an R value of 1, that means your data is really related. That means you totally own the relationship. And it's apparently that strength is entirely based on a beam's depth. And so I got 100%. So we just need to talk a little bit more about kind of how that works. What I would like to show you then, lastly and super quick, is how to do this on your calculator. So bust out your machine. So I'm going to take those numbers that I just graphed a minute ago, and you type these in with me. So I'm going to pull that back up. So we just graphed 4 points here, right? So I'm going to show you how to do this in your graphing calculator and get it to show you a graph. So we're going to go a place we've already been before, which is right here at stat. Again, please interrupt quickly. But if I go to stat, you have two choices again, edit or calculate. Well, I'm just going to stay in edit. We've been here before. And I have some numbers left over here before, and so I'm hitting delete to get rid of them. But now I'm going to type these numbers in. Well, see, notice this time we don't have just one list, we have two lists. And so I'm going to put 5.5 here and hit enter. And so, oh, I'm putting in all of these X values, 9.5, 14, and 20. Those were the three depths, beam depths that we used. They're typically in math called X's. And then the Y's were the shears that went with them were 3658, and then 6318, and then 9310, and then 13,300. So get all those typed in. So this is exactly what you would do in Excel. Like you just type all those numbers in, and then we're just going to say, make me a graph. So it's not all weird. Somebody got in there and messed with it. Now I want you to stare for a second. Look at those X's. They're really small, right? Like from 0 to 20. But the Y values are huge. They're from like, well, a second ago we said 0 to 15,000. So watch what I do here. This is kind of cool. I'm going to go to the zoom button right here. No, wait, window. I think window. Yeah, window. I'm going to go to window. And notice it says your X's. Ours were from, well, I'm going to say 0 to 20. Actually, maybe I'll make it 25. Wasn't that what those values were? They're like between 0 and 25. Whereas the Y values, I'm going to say were between 0 and 15,000. Does it make sense I have to make the graph paper the right size so that we can actually see these things? Again, I have videos stored in my open math to show you how to do this. And so we'll play with it some more in class. We're out of time today. So I'll show you some more, but in terms of how to graph things, there's good videos, good YouTube videos you can look at. Okay, cool. And so right here above mode, it says quit. So I'm going to say second quit to get out of that. And so how do I get it to graph? Well, see this screen right here, y equals. All of these buttons across the top are how you graph stuff. So I'm going to go to y equals. And you see up there how plot 1 is turned on? Basically, that's saying plot. So you need to arrow up there. Yours probably looks like this right now, which is, it's blank. If there's anything typed in here, there's something like 552 x minus 7. If that's sitting in here, go up there and hit clear. Clear is right there. Hit clear so you don't have anything in there. But arrow up there to plot 1 and hit enter. And now you should be able to go over here at graph, and then bam, there's your points. I can see them. And they sure enough are really lined up. Now that isn't necessarily going to work for everybody if it wasn't set up correctly. If somebody messed with it, then it won't be. But the point is, in the real world, we don't graph stuff by hand. We use Excel to graph it. But what's neat about this is it's a graph that doesn't have just one axis, it has two, because we have two totally related numbers. And here I can say, look at that, those are really related, those are really lined up. This is not scattered everywhere. Now, I'll show you something really quick. If yours didn't graph, and I'll come help you with this yourself in just a second, but see how it's right above Y, it says stat plot. So I'm going to hit, to get that stat plot, I have to hit second. So I'm going to hit second stat plot. And so here's plot 1. That's the one I just turned on. Notice for me, it says my X's are in list 1 and my Y's are in list 2. if that, my numbers were in list 1 and list 2, if this doesn't say list 1 and list 2, then it's looking in the wrong place. So if you're said error or something weird like that, that's probably what's going on. Fortunately, you don't have to, you have to just set this once and you never have to touch it again. So if this is set up to say list 1 and list 2, and I'll help you fix it if yours isn't. And notice I said scatter plot right there. I didn't say connect them or make a bar graph. I just said scatter plot, and then second quit. Right above y equals, it says stat plot. So to get it, I have to hit second and then stat plot. And so you can actually graph plot 1, plot 2. There's all kinds of things you can graph. I'm just looking at plot 1. That's the only one you'll ever need to go to in this class. And we're doing this quick. We're going to do this from scratch again next week. So that's okay. And so if that says list 1, list 2, and your numbers were in list 1, list 2, then you can hit graph and you'll actually see graph. So we'll pick it up. We'll pick that concept up again on Monday. So that's good enough for now. So feel free to stay after and work on something to finish it. Feel free to ask me because your calculator didn't work quite right just there. Let me help you fix that stuff.